Welcome to Study Loop.
So what we're given in this problem is the equation, or the function rather, f of x, y, z, t being equal to x plus y plus z plus t. So simple enough. And we know that this given function, it is subject to x squared plus y squared plus z squared plus t squared. So the gradient of f is going to be equal to just 1, 1, 1, 1, clearly. And then the gradient of g, which is another function we have, and that is x squared plus y squared plus z squared plus t squared equals 1. We know that this is just going to give us 2x, 2y, 2z, 2t. With that, we now set those gradients equal to each other because we're dealing with Lagrange multipliers. So what we do is we set each of them equal to their respective components. So it's going to look pretty repetitive. 1 equals all those things. But then we don't want to forget adding the lambda. That's what makes these Lagrange multipliers. So we multiply each component by lambda. And then when we solve for lambda, we'll get 1 over lambda is equal to 2x, which is equal to 2y, which is equal to 2z, which is equal to 2t. So with all that, it's clear that we could just cancel out these 2's, and ultimately what we see is that x equals y, which equals z, which equals t. So since that's the case, we now use this information to solve a little further. So since x squared plus y squared plus z squared plus t squared equals 1, as we already know, we could just say, hey, let's just set everything equal to x. So now we have x squared plus x squared plus x squared plus x squared equals 1. So what that means is 4x squared equals 1, or x squared equals 1/4, and x equals plus or minus 1/2. Now we know that they all have to equal each other. So one possible solution would be f of 1/2, 1/2, 1/2, 1/2. And when we do that, we end up getting 2. And this is going to be our maximum, because if we take f of negative 1/2, f of negative 1/2, negative 1/2, and negative 1/2, what we end up getting is negative 2, and we know that that's going to be the minimum. So these would be the two main values that we want to focus on.